Hello everyone, I'm Soil, and the topic I reported today is marine dissolved organic matter. Can its carbon-nitrogen ratio explain carbon overconsumption? So let's understand some important words that will help me later. DOM. DOM is the abbreviation of dissolved organic matter, like marine life excrement. And DOC means dissolved organic carbon, like humus. DIC means dissolved inorganic carbon, like carbon dioxide. And POC means particle organic carbon, which can't be dissolved in the water, like plankton. And similarly, DON means dissolved organic nitrogen. DIN means dissolved inorganic nitrogen. PON means particle organic nitrogen. So, what kind of carbon do we study? I just said DOC, POC, and DIC. So, what kind of carbon do we study? DIC is very important. And the Redfield ratio, which means the consistent atomic ratio of carbon, nitrogen, and phosphorus. The ratio is about 106 and 16 and 1, found in marine phytoplankton. And in this paper, we just know the carbon and nitrogen ratio is about 6.6. So let's start the introduction. I just said the Redfield is very important, which has become a convenient practice to calculate new production in the open ocean. For example, if we have one unit nitrate consumption, how about carbon consumption? We just multiply 6.6 to calculate the carbon consumption. But pay attention, the carbon and the nitrate consumption here means the uptake by primary producers. However, in a number of cases, the simple Redfield is different from observation. It's very strange and confusing, especially for short periods and at specific localities. So the scientists found the uptake ratio of total CO2 and nitrate in the surface ocean markedly exceeds the Redfield ratio. It means the carbon and nitrate ratio is more than 6.6. So their examples include coastal and shelf seas and the open ocean, especially during phytoplankton blooming. It's very surprising, like this picture. So, low nitrate DOM has been discussed as a possible cause of carbon overconsumption. Here, low nitrate DOM means the high carbon nitrate ratio. So what does this paper study? Whether low nitrate DOM is a possible cause of carbon overconsumption. Next is the material and methods. First, let's talk about the voyage. The place is in the open North Atlantic, and the date is during June 25th to July 14th in 1996. And the voyage starts from the 60 degree north to 33 degree north along the 20 degree western meridian. And we assume the northern point is the spring and the southern point is the summer. Next is the sampling. On the surface, we use a continuously operating pump, and the vertical profiles, we use a CTD, like this one. It's a very common equipment in the research ship. And we use the number of the sample is 100, and they will be oxidized by high temperature. Then we will get CO2 and the NO. The CO2 comes from the DOC, and the NO comes from the DON. And finally, we will do a quantitative analysis. And there are many chemical details in the middle. Results. We found accumulating spring bloom at about 51 degrees north with maximum chlorophyll A and POC concentration. So you can see in this 51 so you can see this picture. The exercise is the latitude in north, and the y-axis is the concentration. You can see in the 51 degree north, the POC has a concentration. But note that there was no DOC maximum associated with the spring bloom at 51 degree north. Also in this point, this is not the maximum of the DOC, but we can see that from the south to north, the DOC has a trend to decrease from south to north. In a broad sense, the north to south has a special distribution of a temporal development from spring to summer. And you can see the nitrate content is reduced from spring to summer. And pay attention, we should separate younger DOM from the older. The red part is the younger DOM, is what we need to research. And this picture, the x-axis is the latitude in the north, and the y-axis is the depth. And the other part is the older DOM. So the differences between the younger DOM and the older DOM is based on carbon dating results. And look at these pictures, we should pay attention to the DOC. So you can see in the first four pictures, their DOC on the surface is more than 60 units. But the other two pictures, their DOC on the surface is less than 60 units. And to eliminate the efforts of nitrate, so in this picture, also the x-axis is latitude and the y-axis is concentration. You can see in this picture the nitrate, when the latitude is less than 50 degrees, the nitrate is about 0. So we can eliminate the effort of nitrate. So in the other picture, we also use the latitude less than 50 degrees. So the first four pictures, their latitude is less than 50 degrees. So we use the first picture's data, not the other two pictures' data. And through the data, the aperture yields a carbon and nitrogen ratio of the freshly formed DOM of 23 degree 0.5. It's very bigger than 6.6. In short, DOM of a carbon nitrogen ratio far above the red field ratio had accumulated in surface water. Finally, conclusion and the implications. In the Northeast Atlantic, the formation of DOM can explain carbon oil consumption during summer, but not spring. In summer, low nitrate DOM accumulating contribute to CO2, draw down sea level. But its impact on long-term carbon and nitrogen balance of the ocean is very small. We believe that the mixed layer in winter is bigger than the summer. So, although there are many carbon consumption in the summer, but in the winter when the mixed layer increases, the CO2 or other forms supplementary consumption of carbon. So the CO2 will be implied to the winter. Thanks for your attention.